Okay, this is Mr. Precella, and we are continuing to work on the review for the final exam in college algebra. We're up to writing equations of circles and graphing circles. To write the equation of a circle, you need to know an ordered pair. That's the center of the circle. And we need to know the radius. So this HK, that's the center, and you plug into this. X minus h squared plus y minus k squared equals r squared. Just plug in the h, k, and r. This ordered pair, 4, -3. There's your h and there's your k. And the radius is 6. So I'm plugging in place of the h, I'm putting a 4. In place of the k, I'm putting a -3. In place of the r, I'm putting a 6. Watch out for the minus and negative. We have x minus green 4 squared plus y minus k is a -3. So when I put a green -3, we have the black minus, then another minus, that's the green minus, turning that into a plus, equals r squared. Well, when we put the r in, the green 6 in place of the r, that's just going to be a 36. So x minus 4 squared plus y plus 3 squared equals 36. That's the equation we'll type in. And I can't really show y'all the graphing tool on this sheet of paper, but if you remember how you work that, you click on the little icon to graph a circle, and you plot the point 4, -3. It'll say click on the center. So you click on 4, -3. That would be right there. There's the point 4, -3. And then it would say, okay, now plot another point. So it's like if you were doing a pencil and paper circle with a compass. You put the sharp point there, then you move over 6 units. I'm going to just move up 1, 2, 3, 4, 5, 6. So if I had a compass, which I don't, I put the sharp point here, move up 6, or right or left 6, and spin it around. Okay, so I don't have a compass, and my circle ain't gonna look like anything. But what y'all do is you click on the center. It'll talk you through once you click circle, and then it'll say click another point. Okay. Back to this equation of a circle. If you actually started FOILing this stuff out, you would get an x squared. There wouldn't be a number in front of the x squared other than a 1. And if you started FOILing out this stuff, y plus 3 times y plus 3, you would get a y squared. So the next 2 problems say find the center and radius of the circle. Finding the center and radius is pretty easy as long as it's written with the parentheses. If it's written in this form, to go backwards. In math, you always do it one way, then you do it in reverse. If you had this equation, how would you go backwards? Well, if you look at enough of these, you think, okay, to get the center out of the equation, change the sign of the number in the parentheses with x, Then change the sign of the number in the parentheses with y. To get the radius, since this is the radius squared, you would go, you'd take the square root. So to go backwards, to find the center, change the sign of the number in the parentheses with x. Every now and then you notice I forget and start writing that cursive writing. To find the center, change the sign of the number in the parentheses with x. Then change the sign of the number in the parentheses with y. To find the radius, take the square root of the last number. So it's change the sign, square root. To find the radius, take the square root of the last number. So that's how you find the center and radius when it's written with these parentheses. The two problems we're about to do, someone got overzealous and wrote it spoiling everything out. Okay? So how the heck do we get it written with those parentheses then? Well, to get started, this first number here, the number in front of the x squared, should always be a 1. Like I said a moment ago, if you FOIL this out, you're going to get an x squared. You're not going to get a 4x squared. So if there's some number in front of the x squared, first thing you need to do is divide straight through by that number. So dividing through by 4, we'd have x squared plus y squared plus 10x minus 4y plus 20 equals 0. Now my goal is to get it now rewritten to be something like this with these parentheses. To do that, we're going to do that completing the square stuff. You group the x terms together. So we have an x squared and a plus 10x. Put a plus blank. We're going to put a perfect square here so that we have a trinomial that'll factor as a perfect square. Plus y squared, group the y's together with a plus blank after them, and move that 20 over here, so a negative 20. So I'm going to be adding a blue number and a red number to each side, filling in these blanks. So whatever I add to the left, I have to add to the right. So that's why I'm putting these blanks over here on the right also. Now to figure out the number that goes in the blank, we had a little way of doing that. It's going to be a perfect square. Number like 4, 9, 16, 25, 36. Well, how do you decide what it is? You take half of that number in front of the blank and then square it. So half of 10 is 5. 5 squared is 25. So add a 25 to each side. And then do the same thing here. Take half of 4 and then square it. Notice, if you want to say half of negative 4, well, okay, but once you square it, you're going to get a positive number. So I just say half of 4 is 2. 2 squared is 4. Okay. Now that we've done that, we can factor the three things in blue, the 3x terms, as a perfect square. If you want to just factor it as trial and error, You'll get the same thing in both sets of parentheses. You get an x and an x. Numbers that multiply together to give 25. 1 times 25 or 5 times 5. Well, it's got to be a perfect square, so it's going to be 5. Notice the pattern. You write down the variable, the very next sign, square root of that last number. Okay? So here, doing the same thing, write down the variable. The very next sign is a minus. The square root of 4, 2. Let me draw my arrows. Variable. The very next sign, square root. Equals negative 20 plus 25 plus 4. Is that going to be a 29 minus 20? Are we getting a 9 over here? If you're watching this, there's actually people out there, they just don't speak. So now that we have it in this form with the parentheses, can we do the change the sign, square root? Yeah. So let's see, what's that center going to be? Change the sign, square root. Oh, this is one of those multiple choice where you got to look real closely. Let's see. They all sort of look alike at first. Is it going to be B, negative 5, positive 2, 3? Yeah. Oh. Fewer and fewer of these multiple choice problems in my math lab. Okay, see, back in the day when this was first started, it was all just multiple choice. But nowadays, you get less and less of that. Problem number 13 is another problem just like that. Make sure you got the hang of it. What do I do first here on number 13? Well, here, let me give you all a second as we're trying to write it down. Any questions on this? Every now and then some of this stuff would appear as a review problem toward the end of assignments. The way the homework is set up as you progress throughout it. I'll have problems at the end just to sort of review of stuff we've already done. So number 13, same thing. You start off, divide straight through by 2. Well, whatever that first number is. So here's the equation. You have an x squared plus y squared plus 10x plus 6y plus 25 equals 0. Group the x's together. So we have an x squared plus 10x plus blank. Group the y's together. We have a y squared plus 6y plus blank. And we'll move that 25 over. Negative 25. Plus blank, plus blank. So let me see. How do we figure out this number? Take half and square it. So let me write that out again. Take half and then square it. Now this sounds familiar, maybe like the one I just did. Half of 10 is 25. Excuse me. Half of 10 is 5. 5 squared is 25. So add Add 25 to both sides. Now over here, half and then square it. Half of 6 is 3. 3 squared is 9. Now let's see. I'm now ready to factor it with the parentheses. You write down the variable. Write down the next sign. And then square root of that number you added. So following that same pattern. This problem wasn't the exact same as the other one. No, it wasn't. Okay. Very similar though. Write down the variable, the next sign, square root. Or you could just write out 2 sets of parentheses and factor by trial and error. Okay. You'd still get just a y plus 3 equals, what number do we have on the right hand side? Is that going to be a 9? So is it ready to do change the sign, square root? Yeah. So change the sign, -5. Change the sign, -3. Square root, 3. So this one was similar to the one we just finished doing. -5, -3, radius 3. Is that answer choice A? Any questions there? That was circles. Now we're going to start finding domains of formulas when it's written at, finding domains of functions when the function is written as a formula or an equation. Okay. When you're told to find the domain of a function, there's 2 things you want to avoid. You don't want a 0 in the bottom of a fraction, and we wouldn't want negatives under the square root. By that I mean we can't put a -100 in for x, because that would give us the square root of a negative number. That would give us an imaginary number. Also, we wouldn't want a 0 in the bottom. What number, can y'all tell me what value of x would give me a 0 in the bottom? What x value would give me a 0 down here? Maybe a -11, okay? So on this problem, there's 2 things we want to make sure. We want to make sure we're not getting a 0 in the bottom, and we want to make sure we're not getting negatives under the square root. In other words, we want what's underneath that square root to be greater than 0. We don't want it to actually equal 0, because if it equals 0, you'd have a 0 in the bottom of a fraction. Well, how do we solve an inequality? Well, use cut points. This one's going to be a cut point method problem that's so easy that it's going to seem strange or difficult. I'm going to use cut points to solve this. Well, there's no denominator cut point, but there is a solution cut point. If I solve x plus 11 equals 0, I would get x equals -11. There's not an equal sign on there, so I'm going to use an open circle. So I have one cut point. At -11. Open circle. Now test one of the intervals. What number am I going to use to test? Well, what do I always use? 0. And where would 0 be? Which one of these intervals am I actually testing? Well, that one. When I plug a 0 into the square root, when I plug a 0 in right here, am I getting something greater than 0? 0 plus 11 is greater than 0, true or false?
Yes.
That's true. So, oh, and we don't even have to type it in. It's just multiple choice. What would our interval be? Parentheses, negative 11, comma, infinity. Okay, so answer D. Okay. Seems a little strange or difficult just because it's such an easy cut point problem. There's nothing quadratic, no factoring or anything. Might be worth our time to compare that one and number 15, which doesn't have the fraction. Okay. On this one, since there was that fraction, that's why we just say greater than 0. Because we don't want it to actually equal 0, because that would give me a 0 in the bottom. But here we don't have a fraction. We just have a square root. So we're going to use cut points to solve this. 5 minus 5x is greater than or equal to 0. Is it clear why I'm saying greater than or equal, whereas over here it was just greater than? When there's a fraction, that's when you just say greater than. You don't want the 0 in the bottom. You don't want this to actually equal 0 because you'd have 1 over 0. That's why there's no equal sign here. But for here, it's okay to have a 0 under the square root. So you can have a 0 in the bottom of a fraction. So do the solution cut points. I'm solving 5 minus 5x equals 0. How would y'all go about solving that? I think I'll move the 5x over to the right just so I don't have any negatives. And then divide by 5. So my solution cut point is a 1. There's an equal sign. So close circle. Any questions? Are y'all caught up with me? I'm going through this mighty quickly. I draw a number line. Locate the number 1 with a closed circle. And test a number. Which number am I going to test? Well, 0. 0 would be over here between negative infinity and 1. So I'm testing 0. If I plug a 0 in for x in this statement right here, 5 minus 5 times 0 is 0. So 5 minus 0 is just 5. 5 greater than or equal to 0, is that true or false? That is true, isn't it? So true, false. This one wasn't multiple choice. You got to type it in. So what would I type in? Parentheses, negative infinity, comma 1, square bracket. Any questions? So, if there's a fraction That's when you're solving the inequality with just a greater than 0. If there isn't, you're solving it with greater than or equal. And it's just a very, I hate to say easy cut point problem, but it is. There's no cross multiplying, no nothing to factor or anything. Okay? Any questions there? Let's see. Number 16. To graph this is a piecewise function broken up into two pieces. There's a couple of ways you could do it. You can actually start drawing it out, or you can just analyze it looking at this. One of these pieces is a constant function. A constant function doesn't have any x's in the rule. The function is f of x equals -3 for x is greater than or equal to 1, and -1 minus x for x is less than 1. So if we just picture a big graph, okay, at the number 1, that's when we're changing from one rule to the other. Okay? So just knowing that, you can knock out some of these. The graphs are changing at the x value of 1. It's sort of hard to tell because the way it printed out. Yeah, well, I guess I can do a physical zoom and lift it up. See, on answer choice A, it looks like the graph is changing at -1, right? Okay, it's not changing at 1. Looks like it's changing at -1. Answer B looks like it's changing at +1. So does answer C. And answer D, it's back changing at -1. Can y'all tell what I mean by that? And when we did these in class, or if you watch the videos, I'd give each piece a different color. Okay, so if you want to call this the red one and that the blue one, fine. But this one's a constant function. Since there's not any x's, that's a constant function. And it would be where? To the right of 1 or to the left of 1? We've already knocked out this one, and what was the other one we knocked out? D? A constant function has just a flat line as its graph, and it would be ending with, you look at this symbol to decide between an open or closed circle. So this flat line has what on it? An open circle or a closed circle? Closed, because of the equal sign. So that's enough to know it. Which one has the flat line to the right of 1? Over here, x is bigger than 1 and ends with a closed circle. Well, do I need to do another physical zoom moving up? B has that flat line ending with an open circle. C has it ending with a closed circle. Now, if you want to actually plot points and get the complete graph, okay, but it is a multiple choice question, so you may as well take advantage. The one that doesn't have an x, that's the flat line. It's called a constant function, and it's ending with a closed circle. Why closed? Because of that equal sign. So just do a little functional and graphical analysis to decide on that answer, rather than graphing it all out. Okay? Any questions on that one? Oh gosh. Number 17 is one of these problems that just goes and goes and goes. Okay, I think there's 8 pieces to it. You're finding f plus g, f minus g, f times g, f over g. That's the easiest one to find. Why? You just write f over g. So I'm going to do the f over g first, just because I'm filling that in. 7x plus 4 is f, and g is 2x minus 5. There. So f over g was the easiest one of those to find. To find f plus g, you just write down f and write down g with a big plus in it. So I'm finding this one here. F is 7x plus 4 plus, that's this plus right there. G is 2x minus 5. To find f plus g, you're just going to add the like terms. Combine the like terms. What would we have? A 9x and a minus 1. 9x minus 1. That's f plus g. F minus g is an extra step that you often have when you're subtracting. To find f minus g, you start off by writing down f, but you're going to subtract g. So I'm going to put all of this in parentheses, because what am I going to have to do with, this minus, distribute. So to subtract functions, you got to distribute that minus. So let's see what we'd have. A 7x plus 4 minus 2x and plus 5. Is that going to give us what? A 5x plus 9? 5x plus 9. Now, for f times g, that's what this symbol, this means. Fg, it's f times g. So to do that, what's that 4-letter word that starts with the F that I'm going to have to do here? This is the F times G. 4-letter. Foil. Foil it out. We'd have a 14x squared. Is that going to be a minus 35x? And a plus 8x? And a minus 20. We got 14x squared, negative 35 plus 8, is that a negative 27x? And a minus 20? So 14x squared minus 27x minus 20. Then it starts asking about the domains. So we had some rules about domains. If there are no fractions, let me look this up. If there are no fractions and no square root symbols, the domain is negative infinity to infinity. So 3 of these are pretty easy. The ones that have no fractions and square root symbols. F plus g, F minus, and F times. So you'll just type in negative infinity, comma infinity. negative infinity, comma infinity. Okay. Now, for the domain of f over g, that's going to take a little bit more work. I'll do that here. Domain of f over g. What was that? 7x plus 4 over 2x minus 5. Well, when we're finding domains, we don't want a denominator of 0. So here we'll say denominator can't be 0. So 2x can't be 5. X can't be, would it be 5 over 2? X can't be 5 over 2. It can be anything else. And back in the olden days, we would write the domain as all real numbers except 5 over 2. Of course, we don't do that anymore. We write it out in interval notation. So how would we write out everything except 5 over 2? Well, if you can picture the 5 over the number line, if you want everything except, that would be negative infinity to 5 over 2 union 5 over 2 to infinity. Okay? And that's just a fancy way of saying everything except the fraction 5 over 2, or 2.5. Oh, I don't even know if I can get it all on the screen. Okay. Any questions? Let's see. Oh, one of those difference quotient. It's the f of x plus h minus f of x all over h. There's a 3-step process that we had for finding the difference quotient. I think I'm going to color code how I'm going to go about it. I'll first find f of x plus h, and I'm going to do that in blue. That's the messy part. The next part, the minus f of x, that just falls out really quickly. Once you've found the f of x plus h, you just mark out the negative 6x squared, the 7x, and the 6. And then the over h is quick also. It's that f of x plus h that takes a while. So I'm going to plug the x plus h in for x. That's how you find f of x plus h. So I have a black negative 6. In place of that black x, I'm putting the blue x plus h. Plus 7. In place of the black x, I'm putting the blue x plus h. And then a plus 6. Okay. Now, I will, let's see. Oh, I've got to simplify all of this stuff. You got to start with this x plus h squared. To square x plus h, you don't just square the x and square the h. You've got to FOIL that out. So I'll do that right here. X plus h times x plus h. We'd have an x squared plus xh, first outer, inner is hx, but since I've already written it as xh, I'm going to just continue to write it as xh, plus h squared. I'm FOILing out the x plus h squared. So we'd have an x squared plus, I can combine the 1xh plus 1xh to get 2xh plus h squared. And now I'm going to replace this x plus h squared with all of that stuff. And this is the messy part. F of x plus h squared. Plus 7 times x plus h plus 6. I distribute that negative 6 here and the 7 there. When you're through with that, you've done the hard part. You'd have a negative 6x squared minus 12xh minus 6h squared plus 7x plus 7h. And we still have that black plus 6 that's just dangling there at the end. I'll go ahead and write it down. And that was the f of x plus h. Did y'all follow what I did there? Is this seeming familiar? Now we're going to do the take away f of x. So look down here and mark out the negative 6x squared. Mark out the 7x. And mark out that plus 6. So that, what I just did was those 3 marks is the take away f of x. And now over h. Everything that's remaining, put each one of those terms over h, and you should be able to cancel that green h in each term. Right here, those cancel. The blue h and the green h. Here, on the second one, the green h cancels one of those h's on the top. So I'll just mark out the exponent. I'll mark out that square. And then there. On the last one, the h's cancel. Oh, wow. What's remaining? Let's see. We have a blue negative 12x, a blue minus 6, and a minus 6h, and a plus 7. This is certainly messy, isn't it? Oh, well, write it up here. Negative 12x minus 6h plus 7. Okay. Any questions there? Just continuing to work this out. Number 19 is where we start the fog and golf stuff, which is formerly called composition of functions, which in 6 months' time you're not going to remember if someone says, did y'all do composition of functions in algebra? Now, if they say the fog and golf, you might remember, oh, that sounds familiar. So, let's see. This is find g of f of 39. That means start with the 39, plug it into f, then take that answer, plug it into g. So I'm plugging the 39 into f first. So come up here with the function f. I'd have a 39 minus 4 all over 7. What's that going to simplify to? A 35 over 7. Is that giving me a 5? That was the f of 39. So I take, in words, what am I doing? I take the 39, plug it into f. When I do that, I got a 5. Now, take the 5, plug it into g. So I'm plugging this in here. what would I have? A 7 times 5 plus 6. The 7 times 5 is 35 plus 6. Is that going to give me a 41? So in words, you start with the 39, plug it into the function right beside it, f. Take that. When I do that, when I plug the 39 in, that got a 5. Take that 5, plug it into g. Okay? 20. Says same type of problem. Says find fog -3. Well, in words, what are we going to do? Take the -3, plug it into g. Then take that answer, plug it into f. So I'll start off by plugging the -3 into the function g. So I'm plugging -3 there. That -3 in for x. Ooh, I'm going to use a calculator for that. I'm going to do it just by hand. The -3 squared would be a 9 times 7 is a 63. The -5 times -3, that's a 15 plus 3. What are we getting when we plug -3 in for x? Let's see, that's going to be a 78. Is that an 81? So I plug -3 into g. Why g? Because that's the letter right beside the -3. When I do that, I got a 81. Now plug an 81, plug that 81 into f. So right here in place of this x, I'm going to put a 81. 6 times 81 plus 9. Let's see, 6 times 81, that's a 486. Plus 9, ooh, is that a 495? So, answer A. Any questions there? So, that's what you do if you have numbers after in the parentheses with the fog and golf. If you have letters, just the x, it says find g composed with f of x, suppose it's just the x there. Then that means you're going to plug f of x into g. This is the arrow stuff. Not a lot of work to it. By that I mean not a lot of scribble. Scribble is really pretty much just those arrows. So I'm plugging f into g. So I'm plugging this into g. So I'm just going to write out the answer. In place of that black x, I'm putting this square root of x plus 3. So I'd have a -7. A fraction bar, and this square root of x plus 3. When I was doing these in class, we did a lot more with the color. I'm specifically trying to tone down the color because when you look at it, it's just black and white to y'all. You don't have all the colors. So, okay, which one is it? I put the negative up on top. This is multiple choice. It looks like they put the negative there in front of the fraction. And that's what I should have done, was put the negative because it was in front here. I'm not sure why I put it up there. But there. 21. If you're thinking, well, gosh, it looks like you just read the problem and wrote down the answer. That's what I did, isn't it? But I made a few, I drew some arrows and that was it. Now for the next one, I think I'm going to color code this. By that I mean I'll write out f of x is the blue one, g of x is the red one, and the first thing we're doing is finding fog x. So I just finished saying I was going to get away from doing it with the color, but I'm doing it with the color anyway. So let's see, this f of g of x means plug g into f. So let me see, I'm plugging g into f. So in place of that blue x, I'm going to have a red 1 over x. And I guess I could think of that 5 as 5 over 1. And to multiply, you just multiply straight across. So it's going to be a square root of 5 over x. Oh, this one's not multiple choice, is it? There's some upsides and downsides to the multiple choice. I like the multiple choice, it's easier to type in, but one of the downsides to a lot of those multiple choice ones don't have the view and example. So if you're a view and example person, it's just not available. So we have f of, now I'm going to do the golf x. I'll write it out again. F of x is the square root of 5x. G of x 1 over x. We're looking for g composed with f of x. Let me draw my arrows. This one in particular, it's going to look like I'm just drawing arrows and writing the problem and writing the answer. I'm plugging f into g. So I'm plugging f into g. So I have the red 1 over, but in place of the red x, I'm putting the blue square root of 5x. So it's 1 over the square root of 5x. Any questions there? I think we'll take a break now. We've done an awful lot today, so we'll continue working on these review problems another day. Okay, so this is Mr. Precella. Thanks for watching.